Good morning, class, and welcome to this lesson on Circuits 9 series circuits. Today, we will be able to solve for current, resistance, voltage, and power in a series circuit. Okay, so I'm going to give you 6 rules, and then I'm going to go through an example of solving for all of these in a series circuit. Okay, so here we go. In a series circuit, current has a single pathway. Therefore, the current through each device is the same. So, first off, let's talk about that. Series has a single pathway. Notice this battery here. There's a battery. There's one path to go down. There's no branching off and going down different paths. It's just there is one single pathway from the positive terminal to the negative terminal. One pathway. And the current through each device is the same. So in this example, the current is 2 amps. We see it right here. That means the current is 2 amps right here, it's 2 amps right here, and it's 2 amps right here. The current through the whole thing is 2 amps because in a series circuit, current is constant. Okay? Next, the total resistance of the circuit is the sum of the resistance of the individual resistors. So I have 2 resistors in this example. I have a 5 ohm resistor and a 1 ohm resistor. So if I want to find the total resistance, or sometimes we call it the equivalent resistance, equivalent or total resistance, could be one or the other, okay? Equivalent or total resistance. The total resistance in a series circuit is equal to the resistances added up from each resistor. So in this case, I have a 5 ohm resistor and a 1 ohm resistor. Therefore, my total resistance is equal to 6 ohms. Okay, not that difficult. Okay. Next, the total current is equal to the voltage divided by the total resistance. So if I look at this circuit right here, my voltage is 12 volts. V equals I times R, and I want to know the current. So current is equal to V over R. My total voltage is 12 volts. My total current, which I found right here from adding up R1, R2, and there's more, R3, R4, is going to be equal to 6 ohms. Therefore, my current is 2 amps, like we saw earlier. Okay, so that is rule number 3. That is rule number 3. Okay, let's go to the next page here. Same picture. Rule 4. Ohm's law applies to each device. The voltage across each device is directly related to its own resistance. So notice I said the voltage across each device. There is going to be a voltage, excuse me, there is going to be a voltage drop or a voltage or a potential difference, I'll write that down, drop, not drog, or a potential difference across each device. Okay? So, V equals I times R. I know that my total current is 2 amps right here. So, V equals I, 2 amps times 5, 2 amps times 5 ohms, which equals to 10 volts. V equals 2 amps, remember, because current is the same, times 1 ohm, so 2 volts. Okay, so this is the voltage drop across each device. Okay, this is going to, and rule number 5, the voltage drop potential difference across each device is going to add it up equals the total voltage. I have 10 volts and 2 volts. My total voltage is 12 volts for the whole thing. Notice my battery is 12 volts. Okay, perfect. The power delivered to each device added up equals the total power for the equivalent resistance. So, in this case, power equals I times V. I can use any of my, you know what? Let's go back. My total resistance is 6 ohms. 6 ohms. And one of my equations for power is P equals I squared R. So in this case, it's going to be 2 squared times 6, or 4 times 6, so I get 24 watts. There's going to be 24 watts of power delivered to this entire circuit, okay? And if I calculate that for each one of these, for each one of these. So if I did P equals I squared R for each one, actually I'll do a different formula just to mix it up a little bit. Let's do P equals I times V. P equals I times V. So power is going to equal 2 amps, or current's going to equal 2 amps. And the voltage for this resistor right here, is going to be 10 volts. P equals I times V, so 2 amps times 2 volts, or excuse me, 2 volts for this one. So 2 times 10 is going to be equal to 20 watts. This is going to be equal to 4 watts. So notice when I take my total resistance and my total current, I found 24 watts for the whole circuit. And then when I did power for each one, notice I was using the voltage for each one, not the total, not that one. For each one, I got 20 watts and 4 watts. So these are the 6 basic rules for series circuits. I'm going to do this whole thing again with a different circuit just for practice, okay? So let's draw a circuit here. Okay, circuit with 3 devices. Here is a 60-volt battery. This R1 is going to be equal to 6 ohms. This R2 is going to be equal to 14 ohms. And this R3 is equal to 10 ohms. Okay, so we are going to find the total or the equivalent resistance. We are going to find the total current. We are going to find the total current, and we're going to find the total power. Okay? We are also going to find the voltage across each resistor. We are going to find the current for each resistor. And then we're going to find the power for each resistor. Okay? So we're going to go through the whole thing, okay? So let's start off with total resistance. In a series circuit, R total, or R equivalent, is equal to R1 plus R2 plus R3. 6 plus 14 plus 10. 6 plus 14 plus 10 is equal to 30 ohms. Okay? The total resistance is just going to be using Ohm's law, which is going to be using Ohm's law, okay, which is our rule number 3. So that's going to be V equals I times R, or I equals V over R. So our total voltage is 60 volts divided by 30 ohms, our total resistance. So our current is going to be 2 amps, just like in the last example, okay? That's our total current here. Okay, now we can start filling in some of these blanks here, okay? I can't guarantee that this is going to be the exact setup for every single problem you have, but if you understand these rules, then you can always go backwards or forwards depending on how we're doing this. We know in a series circuit, rule number 1, the current is the same through each device. So our total current is 2 amps. That means the current through each device is 2 amps. Okay, that's an easy one. That's an easy one. Okay? So now what's going to be the voltage across each device? The voltage across each device. Well, V equals I times R. So we're going to have 2 amps times the resistance of each device. So it's going to be 6 ohms, 14 ohms, and 10 ohms. So we get 12 volts, 28 volts, and 20 volts. Okay? 12 volts, 28 volts, and 20 volts. And if you notice from rule number 5, the voltage drop across each device added up equals total voltage. 12 plus 28 plus 20. 20 plus 28 is 48. 48 plus 12 is 60. The total of this, the total is equal to 60 volts. Okay? So I'm just verifying those rules there, okay? Let's erase all this. Okay, let's do power. Let's do the total power now. The total power is equal to the equivalent resistance. So why don't we use Actually, you know what? I'm going to do all three equations just to prove it to you, okay? P equals I times V, P equals I squared R, and P equals V squared over R. The total current is 2 amps. The total voltage is 60 volts, okay? The total current is 2 amps squared times the total resistance, 30 ohms, and this one 60 volts squared divided by 30 ohms. In every single one of these, it doesn't matter what equation we use, we get 120 watts. 120 watts. Okay, so we'll put 120 right there. All right, that's good. Notice once again we use a total resistance there. Now our last one is going to be finding power for each one of these, and so notice in all of these I'll use the resistance. I'm going to use the resistance of each individual resistor. So P equals I squared R. I'm going to pick this equation for now, okay? P equals I squared R. So I squared R for P1 is going to be equal to 2 amps, because that's the same throughout, times R, which is 6 ohms. Okay? Oh, 2 amps squared. Okay? 2 amps squared, 2 amps squared. P2, P3, times 14 ohms, times 10 ohms. 4 times 6 is 24 watts. 4 times 14 is 56 watts, and 4 times 10 is 40 watts. If you notice, if you add all these up, you get 120 watts. And I'm going to be just a little bit thorough here. Let's go back, and I'm going to do the same thing again, but I'm going to use a different equation. P1, P2, P3. I'm going to use P equals I times V. 2 amps, 2 amps, 2 amps. Okay? But notice when I use voltage, I'm not going to use the total. I'm not going to use a total. I'm going to use the voltage drop, or the potential difference, across each resistor. So I'm going to use these three right here. 12 volts, 28 volts, or 20 volts. 2 times 12 is 24. 2 times 28 is 56, or 2 times 20 is 40. So that is series circuits for you. We have covered current, resistance, power, and voltage in a series circuit, which is a single path from the positive terminal to the negative terminal.